Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of attributes of similarity. This is standard 7.5a in the great state of Texas, and we are using item number 11 of the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So the only thing we know about these two triangles is they are similar. So what does that mean for us? So similarity means we have the same shape. So you cannot say two shapes are similar if one's a rectangle and one's a triangle. Exact same shape. And we also have the same angles, same or congruent angles. So the difference then is simply the size, the scale. The side lengths are different. But you've got these angles match up. This angle right here matches with that one right here, and so does this one. So the difference is merely the scale. But when the scale is different, the side lengths are different, that means they are proportional. And you can actually use proportion to find missing lengths. So that's what we're going to do here. So let's check each of these. And there's two different ways that we can do our proportion. All right, so we could have let's start with this first one. We'll see which one we have here. We've got 7.5, so I'm just going to label that as HK. So that 7.5 is right here. Over 11.25, so that is ln. So what this one is doing is this is a proportion, and in the original equation right here, we've got small to big. So the proportion is across shapes. So in order for it to work, we just need another pair of side lengths from, it needs to be small to big, but they need to match up like HK and LN. So I've got 11 point, let's see, LM, right? That's what we're missing here is this LM. So LM, but you notice the problem, LM's on the bigger one. It matches up with HJ, but if you would flip these, it would be good. But it needs to have, if you've got small in the numerator, you need small in the numerator, and LM is the big one. So no for A, but that's how we're going to look at it. Let's take 6 over 7.5. So this is another one. So you're doing a proportion within the same shape. So you've got JK over HK. So these are both small. So that's the other way to do it. So instead of small to big, you can have small to small, which is fine. You just need big to big over here, but you need to find the corresponding angles. So this LM, you see, and here's the problem. This LM doesn't match, here's LM, it doesn't match JK. So if JK was on top right here, what we should have had was we should have had MN, that 9, which is what we had. So we unfortunately just flipped those. If you were to flip these, they would go because JK actually matches up with MN and HK matches with LM, but they need to be in the numerator and denominator switch. So B, incorrect. Let's check C, 11.25, so that is LN over LM. So we're going to do big to big, that's fine. So we just need small to small, but we need matching. So 4.5 is HJ. So does LN, diagonal right here, match up with HJ? No, it doesn't. Those are the different ones. And then it's over 7.5, which is your H. Yeah, HK. So once again, that one matches with that one matches with that one. If you flip them, they're good. Let's hope our answer is D. So we've got 9. So that is MN over LM. So you've got big to big, we just need corresponding small to small. So 6, which is JK. So here, does MN match with JK? Yes. And then you've got 4.5 with this HJ. That's also on the small side. So does LM match with HJ? Yes, it does. Finally, after all that work. So our answer is going to be D. We can use this proportion to find LM.